So in that example, it says sine squared theta plus cosine 2 theta is and minus cosine. So what the issue with that one is not only do I have a sine squared, like not only do I have a sine mixed in with the cosines, but I also have a 2 theta mixed in with a single theta. So there is a lot happening here, okay? Now, the bigger issue to deal with is that you have a sine mixed with some cosines, okay? So for this one, right, we are going to use one of the identities here. So sine squared theta is 1 minus cosine 2 theta over 2. And then I have plus cosine 2 theta minus cosine theta equal to 0. Now, I don't like that 2 there. So I'm going to multiply everything by 2 on both sides of the equation. So I get 1 minus cosine 2 theta plus 2 cosine 2 theta minus 2 cosine theta equal to 0. Okay, now, look at this. I have like terms. Negative cosine 2 theta, positive 2 cosine 2 theta. So those I can combine. So I have 1 plus 1 cosine 2 theta minus 2 cosine theta equal to 0. Okay, so now at least I got rid of the sign. Now my issue is that I have a cosine 2 theta mixed with a cosine of a single theta. I can't have double theta and single theta in an equation and expect to solve. So what I'm going to do instead is I'm going to use one of the identities for cosine 2 theta. And the only one that makes sense to use here is the one with just a cosine. So what I have is 1 plus 2 cosine squared theta minus 1. And then minus 2 cosine theta equal to 0. Okay, now 1 minus 1 goes away. So what I'm left with is 2 cosine squared theta minus 2 cosine theta equal to 0. You can take out a 2 cosine theta. And I have now cosine theta left minus 1. Right? And now this is law of, this is zero product property. So I can say 2 cosine theta is equal to 0. Cosine theta minus 1 is equal to 0. So where is cosine equal to 0? At pi over 2 and 3 pi over 2. And here cosine theta is equal to 1 at 0.
Wait. Can it not be pi 2 plus pi?
Okay, yeah, I'm not there yet. But now, look, this says just solve. It doesn't tell you to solve from 0 to 2 pi, right? So I have to do the, plus 2 pi n. So pi over 2 and 3 pi over 2 are 180 degrees apart. So I can just do pi over 2 plus pi n. So that's one answer. Here, it's 0 plus 2 pi n. So it's just 2 pi n. And that's the second answer.
Is it okay if you write 0 plus 2 pi n?
We normally just do 2 pi n because 0 plus anything is the same number. Okay. All right. So we did double angle identities. We could also do half angle identities. So look, 45 degrees is a wonderful angle to have to deal with, right? It's on the unit circle, it's pi over 4, it's amazing. What if you have 22.5? That's a mess of an angle. But 22.5 is exactly half of 45, right? And if I know how to deal with 45, I will now also know how to deal with half of 45, right? Same with, I'm really cool with 30 degrees. But now if I'm faced with 15 degrees, not so cool, but wait, it's half of 30. I can deal with half of 30. Yeah.
I'm guessing this doesn't apply to 60.
Right, well, 60, yeah, half of it is already 30, so 60 is good all around. Yeah. So the half angle identities are these. Now, you have you have sine of theta over 2, okay, equal to 1 minus cosine theta, blah, 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 divided by 2. Now, these are for the half angles. It's important to know that the theta in here is the full angle. Right? It's the full angle, 30. So for example, this, right? You know how it says sine of theta over 2? Like it's sine of 30 over 2, right? So that angle, if I'm dealing with 15, what's 15? It's 30 over 2. So that angle theta is this 30. Okay? Let's do a couple problems and you'll see. Like this is theta over 2, so this is 15, but that's the full angle 30. And just like the ones before, I have one for sine, cosine. This time tangent has the 3 varieties, and that's fine. We deal with it like we dealt with the cosine. All right, so look at this one. It says find the exact value. Remember what exact value means, no decimals, right? Of sine of 22.5. All right. So now, sine of 22.5 is a half angle, okay? So this is the same as sine of 45 over 2, okay? Now, the one thing you have to notice is this angle 22.5 is in quadrant 1. Just take note of that, because remember how sometimes the quadrants switch? Just be mindful of that. Okay. So, what I need to find is sine of 22.5, right? Okay. I'm going to use a half angle identity for sine. I'm going to use that one. The identity says this is equal to plus or minus 1 minus cosine of theta. And we said theta was the full angle of 45. That's where it comes in, right? If you put 22.5 in here, you're still out of luck because you still don't know how to do cosine of 22.5. But if you put cosine of 45, then you can work with it. All over 2. Now, you see how there is plus or minus here? Okay. Where did we say our angle lies? In quadrant 1. In there, sine is positive. So I take the positive. No, but 22.5. Well, 22.5. Yeah. Okay, so since 22.5 is in quadrant 1. Okay, so now I'm pretty much done. So now I do positive the square root of, okay, 1 minus, what's cosine of 45? 1 over root 2 over 2. Now, Let me show you. Okay, now you have to do you have to simplify this fraction. The quickest way to do this is, you see how there is a denominator here? Multiply the top and bottom of that main fraction by that denominator. So multiply everything here by root 2 and multiply this by root 2.
I think it'll be easier if you add it as root 2 over 2 because then you can just...
You're still going to have to multiply everything, okay? So now, if I distribute the root 2 here, I have root 2 times 1 minus 1 all over 2 root 2, right? Yeah? Huh? So now, okay, so you can leave it like that. However, in the book, things will be a little bit different. So you can rationalize this, right? How would you rationalize this? Multiply by root 2, multiply by root 2 again. So here I get the square root of 2 minus root 2 over 4. And now this is the square root of, you can split up the root, 2 minus root 2 over root 4, which is 2. Okay, nope. A root inside of a root, it just stays the way it is. It's a beautiful thing. All right? So that is fine, or this as well. Okay, both of those are okay. Well, the middle step, you may as well, once you have this, you should take it out of the root, right?
Why do you multiply by root 2 and why do you do it again?
I multiplied by root 2. I only multiplied because you can multiply by whatever this denominator is to get rid of it. Then I did it again to rationalize.
But if it was root 2 over 2, would you just multiply by 2?
Uh-huh. Yeah. Yeah. Okay. So look at this one. Here I have, right? Here I have sine squared x over 2 equals cosine squared x over 2. Okay, that kind of looks intimidating. But you know what? Why don't we write these like this? Sine of x over 2 squared equals to cosine of x over 2 squared. You can do that, right? And now, can I take a square root of both sides? Why not? And when you do that, yeah, you get sine of x over 2 equal to cosine of x over 2. Okay, now, sine of x over 2, that's a half angle identity. Do we have a half angle identity? That one. Cosine of x over 2, that's a half angle identity. So why don't we substitute each of those identities in there? So for the first one, I get plus or minus the square root of 1 minus cosine theta over 2 equals plus or minus the square root of 1 plus cosine theta over 2. Oh my God, intense. What can I do now? Square both sides. 1 minus cosine and then 1 plus cosine. Okay, when you square both sides, everything becomes positive, right? So you can also get rid of the plus or minus. So now what I have is 1 minus cosine theta over 2 equals 1 plus cosine theta over 2. What happens to the 2's? They cancel out, right? Because you multiply both sides by 2. So we have 1 minus cosine theta equal to 1 plus cosine theta. A 1 cancels out from both sides. Yeah, and then I can add cosine theta to both sides. So I have 0 equal to 2 cosine theta. And when is cosine theta 0? Pi over 2, 3 pi over 2. Okay? And it says it's from 0 to 2 pi, so that's good enough. Okay? You see how everything just sort of like falls into place? That is so cool. Okay. All right. So now, product to sum identities. This shows up in calculus where you have like cosine of an angle times sine of a different angle, right? So what this is the product of two trig functions with different angles. All right? And again, basically what it boils down to is you just have to recognize that there exist identities for when you have sine of an angle times cosine of a different angle. All right? And then all you have to do is look on your sheet and match with the one that exists in the sheet, right? So these are the angles. Look, sine of an angle, sine of a different angle. Cosine of an angle, cosine of a different angle. So now you have this problem. Cosine of an angle times cosine of a different angle. So if I label these 1, 2, 3, 4, which identity will I use for this one? 3. Yeah. So use 3.
So just to clarify, x is like the same number in both terms. It's just like what they're being multiplied by.
Right. One is 5x, one is 3x, and so on.
So that's
Yeah.
Okay.
Okay. So cosine 6x, cosine 3x. So that's gonna equal 1/2 of cosine alpha minus beta. So 6x minus 3x plus cosine 6x plus 3x. This is 1/2 cosine 3x plus cosine 9x, and you're done. That's it. Students will try to do all sorts of stuff, like divide 3 by 2 and 9 by 2. You cannot do that. You're not allowed to do that. That's it. We're done. This is it.
Should we know why we can't do that, or is that?
You should know, yeah, because it goes to, if you have half of sine of 30.
Oh, I get it. Okay.
Right? It's half of a half.
Half of that.
Right. It's not sine of 15.
Okay.
Correct. Okay?
So why? We don't know what cosine is.
Right. Yeah. Yep. Okay. And then you have sum to product. So you have sine of an angle plus sine of another angle, and so on. So if we label these the same way, 1, 2, 3, 4, which one do we use for number 8 here? 2 it is. Cosine, cosine. So this is going to equal 2 cosine. No, this is the new one. No, they're new. One is product to sum, one is sum to product. Yeah. 255 plus 195 over 2. And then cosine 255 minus 195 over 2. This is 2 cosine. All this will be 225 times cosine. All this will be 30. Oh my God, look at that. This is 2 times. What's cosine of 225 these days?
I know. Cosine of 45.
1 over root 2, but is it positive or negative?
Negative.
Negative 1 over root 2. And what's cosine of 30? Root 3 over 2. All right? So look, this 2 cancels with this 2, and you have negative root 3 over root 2. Right? Did you know before you came here today that you could have done cosine of 195 plus cosine of 255 without even using a calculator? Who would have thought? Who would have thought? All you need is a sheet of identities, and then we are set for life. Yeah.
Would you also accept negative root 6 over 2?
Yep. Okay. Yeah. Ooh. Okay. Here we go. Sine of 8x minus sine of 2x equals 0. You can't do anything with those. You can't combine them. You can't do anything with them. Question? Yeah. But you can. Okay, so here's what happens. You're sitting there, you take this, and you're just like, oh my God, what do I do? And then you go, wait, there's an identity for that. It's like, you know, there's an app for that. There's an identity for that, right? So there is an identity for that. Which of these identities is for that one? Use number 3 here, exactly. So, and listen, I don't know those by heart. Every single time I need to look back. So don't even attempt to memorize them. Just, you're going to have them on the sheet. Just copy them over. All right. Yeah.
How did you know to use the third one?
Because what you have here is sine of an angle. Yeah.
For some reason, I labeled the top right.
Oh, yeah. Yeah.
That's what I did.
Okay, so now, what are we going to do here? Okay, so it's 2 cosine a plus b over 2. So 8x plus 2x over 2 sine 8x minus 2x over 2 equal to 0. Right? So now I have 2 cosine 5x sine 2x equal to 0. No, 3x. Look at what we did. We converted to zero product property, right? Now I have something times something equal to 0. And I can then set each equal to 0 on its own, right? That's the benefit of using that identity. So the 2 will go away, right? Because you can divide it out. So now I have cosine 5x equal to 0, and leave some space here. We're going to need to work. Sine of 3x is equal to 0. Okay? Now, where is cosine 0? At pi over 2 and 3 pi over 2. Okay, so now, hear me out here. Cosine is 0 when the angle is pi over 2 and 3 pi over 2. Okay? So, cosine of theta is 0 when the angle is pi over 2, 3 pi over 2. In this purple problem, what is the angle? The function is cosine. What is the angle? 5x. So cosine is 0 when the angle is 0. Meaning, when 5x is equal to pi over 2 or 3 pi over 2. Okay? So now, when I divide this and solve, x is pi over 10 and x is 3 pi over 10. Does that make sense? Let's see. Let's take pi over 10. Let's check. We have cosine 5x is equal to 0. Cosine 5, what's x? X we got to be pi over 10. Is this equal to 0? Well, this is cosine of what? Pi over 2, and that is equal to 0. You see how that works? All right? So, when the angle here, when it's not cosine or sine of x, when it's a multiple of x, then you say, okay, where is it 0? Where you set the whole thing equal to pi over 2 and 3 pi over 2. So x is 10 and x is 3 pi over 10. But now, what about the 2 pi n and stuff? What happens then? Okay, let's think about this for a minute. If you have y equals cosine 5x, what's the period? Period is 2 pi over b, which is 5. So the period is 2 pi over 5, right? So take a look. This is 2 pi. Traditionally, cosine would look like that, right? But now, where is 2 pi over 5? Right here. So now, cosine 5x looks like that. It's a much smaller one, right? So here, instead of doing pi over 10 plus 2 pi, we have to do pi over 10 plus 2 pi over 5. Okay? N. And here, we have to do 3 pi over 10 plus 2 pi over 5n. Okay, let me show you another way to do this. You might like that better. I had cosine 5x is equal to 0, right? Where is cosine is equal to 0? At pi over 2. Right? Yeah. So here's what you could do. You could do 5x is equal to pi over 2 plus 2 pi n. And then divide by 5. So you get x is pi over 10 plus 2 pi over 5n. Yeah. Okay? All right. Now, so that's one answer. We still have 3x, sine of 3x equal to 0. So when is that going to happen? When does sine equal 0? At 0 and pi and 2 pi, right? So we say 3x is equal to 0. 3x is equal to pi. But now it's also going to be plus 2 pi n. Is that right? So let's do 3x equals 0 plus 2 pi n. 3x equals pi plus 2 pi n. Okay. Now divide by 3. So x is 0 plus 2 pi over 3n. X is pi over 3 plus 2 pi over 3n. Yeah, so I do it the first way because I want you to know what it is conceptually. But then this is better, like, practically. So everything in the green is the answer.
Can we put x equals 0 plus 2 pi over 3n?
I prefer the, yeah, not 0 plus. Okay, yeah.
Why don't you have to, you have to include 2 pi, so now it's equal to 0 pi.
Yeah, but yeah, so when you do this, you just take care of all of it. Yeah. All right. Yeah, because the 0 takes care of it.
So the answer would only be the right side.
Everything in the green. Everything, all of this green.
Why would,
Because
the second half of this segment? Okay.
So we got this from cosine 5x and then sine 3x. So all of the greens are the answer.
I understand that.
Mm-hmm.
Like, on the right side, wouldn't the right side of the right side take care of the left side of the right side?
I know what he's saying. I agree. Because I think he's saying like since it starts at power 3 plus 2 power 3n, at some point it will reach 2 power 3n.
Yeah. That's fine. Yeah. That's
so
fine. Right. You could just do 2 power 3n.
And then that would.
Yeah.
And then couldn't you also do that for the first part? Couldn't you also just do pi over 10 plus 2 pi over 5n? Because that would satisfy the other side as well.
If you can do that, it's fine. I know with this, it takes like a little bit to like process. So yeah, either is fine. Okay. Do you remember how way back in the day, like 3 days ago or whatever it was, we did these verifying, right, stuff? Remember how like this was an identity and they were like, yeah, so prove it, right? We're going to do the same thing here. Do you guys recognize this identity? It's page 1 of section 5. This is one of the 3 identities for cosine 2 theta. All right? So now it says verify this. Okay. Well, how am I going to verify? You know what I'm going to do? Because there isn't enough space there, I'm just going to rewrite that in the middle here. Cosine 2 theta is equal to 2 cosine squared theta minus 1. So verify that cosine 2 theta is in fact that. All right, so remember how before when we had like sine of negative theta, how did we rewrite the negative theta? Or we did 0 minus theta, remember, for negative theta? We're going to do something similar here. We're going to rewrite this 2 theta as theta plus theta, right? Because you could be 16 years old or you could be 8 plus 8 years old. Same thing. So cosine of theta plus theta. So now look at what we have. We have a sum and difference. This is the cosine, cosine, sine, sine, right? So this is cosine minus sine, sine. So now what is this? This is cosine squared theta minus sine squared theta. Does that mean anything to you? Yes and no, right? Because yeah. Well, okay. Well, let's do the Pythagorean identity. Sine squared theta plus cosine squared theta is equal to 1. So how much is sine squared theta? Based on that. 1 minus cosine squared theta. Right? Oh, I see what you're saying. Yeah. It's not half. Yeah, they add up to 1. So this is going to be cosine squared theta minus, and now sine squared theta is 1 minus cosine squared theta. And now look, we're almost there. Because now I have cosine squared theta minus 1 plus cosine squared theta. And now look, like terms. What is that?
2 cosine squared theta.
2 cosine squared theta minus 1 is equal to, sure enough, 2 cosine squared theta minus 1. That is true. So originally, right, we had the Pythagorean theorem identities. And then somebody said, hey, what if you have cosine 2 theta? And then they just started fiddling with it. And they're like, oh, that means cosine 2 theta is equal to this. So that's where the double angle identity came from, right? It's not like somebody went fishing and this is what they like fished out of the pond, right? Like people just came up with this, and it's nothing mysterious. You just use one identity to plug into another identity. Yes.
Just an overall question. I noticed sometimes the question.
All right, so this homework in its entirety will be due when? Wednesday? Do we see you? Yeah, Wednesday. Right? So this is going to be due Wednesday.
I'm always